Hi, welcome to the Atmel Edge, the show that makes you well-rounded and well-grounded. I'm Paul Rako, and this is our first schematic segment, and in the well-grounded theme, we're going to talk about grounds. It's a much more difficult subject than you'd imagine. It's not just a little symbol on the page, on your schematic page. So let's delve into grounds, and there's going to be a whole series of shows that we're going to talk about grounds. Let's get started. Okay. So let's talk about grounds a little bit. We've got our 11 by 17 Staples tablet here. Cool guy stuff. 11 by 17 is just a good size for engineering. You can fold it up so it goes in a ring binder. Some people call it ledger. Some people call it B size. Go down to Staples and get this beautiful graph paper. Now, if you look at a lot of app notes, a lot of magazine articles, you see people using for a circuit board ground this symbol. That's wrong, because this symbol is earth ground. Has a very precise meaning and a very precise name, and it's earth ground. My professor, James T. McLaughlin at Kettering University, now previously General Motors Institute, he pointed out earth ground is a 10-foot copper-clad steel rod, and you hammer it into the dirt and you make sure there's moisture so it has conductivity. That's earth ground. The minute you hook a wire to it, well, now you got some inductance and 12-gauge wire all the way to get to where earth ground has to get, which is this third pin on your wall socket. Well, now it's got a little resistance as well. So earth ground means earth. My friend Kirkwood Rough, I mentioned this topic to him the other day. He consults to semiconductor companies, machinery companies. He said, well, actually, the copper rod, we used to do that for like E-beam machines. It's not good enough. Because what would happen is the hole they drill in the concrete in this big slab of a building would tend to be in the middle, and it's dry underneath because rain doesn't fall there, so they wouldn't get good conductivity. He said, if you want a real earth ground, find the steel structure that goes down to 100% resistance at the water table. Hook a big braided cable to that, and now you not only have an effective earth ground because it's a lot of surface area going down multiple places, but you also have a cage because the steel can help shield interference away from your machinery. So earth ground means earth. The same professor I had, James T. McLaughlin, he would flunk you for the whole semester because we were doing mostly car electronics. If you used this ground symbol on a schematic, sorry, a car isn't grounded, it has rubber tires. What you want to use is this symbol, which is chassis common. And chassis common, it's not just cars, but television, radios, PCs with metal things. Anywhere there's a metal case or a metal mounting point, that's chassis common. In America, if a human being can touch that metal, you have to connect earth ground at chassis common. You use Underwriter Laboratories requires a ring terminal so it doesn't get pulled off. And that way, if there's a short of high voltage onto the chassis, a wire or something falls down, then it can seek a ground through this earth ground and trip a circuit breaker instead of electrocuting your customers. Always a good thing. Now, semiconductor companies who make chips should be using this symbol, the triangle. That is power supply return. Power supply return, yeah, you may have your circuit board in the corners. It may connect to chassis, and maybe you want that. Maybe you want it to connect at 100 places to get a really good RF connection between the circuit board and the metal chassis. But this symbol would be improper on a circuit board, and certainly earth ground is wrong. And we're going to go over all of this. There's a ton of examples I'm going to show you. In my experience, in my friend's experience out here in Silicon Valley, places where people got in trouble. Now, just regarding power supply return, well, you have a ground plane. Ground plane. And you say, oh, well, on my ground plane, we use that just sloppy, the ground plane on my board. It's not really a ground plane unless it connects to ground, and it probably doesn't. Not locally, at least. It goes through screws in the chassis and rivets and finally gets to ground. Henry Ott, famous consultant, wrote some brilliant books you should read. I met him and he said, Paul, where is the ground plane in a satellite? Let's say you're designing satellite or avionics. Can't have a ground plane because you don't have access to ground. There's no connection. It's like the car with the rubber tires. So he prefers the expression reference plane. Reference. And that's your reference. And Henry has, when we get to PCB layout articles and videos, we'll talk about some of Henry's principles, how to get you out of trouble. So you have to understand the difference in these. If you submit something to UL that's all full of this earth ground symbol on a circuit board, they'll say, well, that's not really correct. You should be using a common power supply return. Then you have to go into your schematic package and change all the symbols, and maybe the net list is named different, and unbelievable problems can occur. So it's important to be diligent and use the right symbol first from the beginning. And there's more to come about cutting up planes and why that's bad. And single point grounding, we're going to get in a big argument with the automotive or with the audio people who love single point grounding. I'll tell you why it usually causes more problems than it solves. So in future shows, I have a story about a big semiconductor machinery place where I consulted. They had a machine reboot and break hundreds of thousands of dollars of wafers because they didn't understand ground, shield, return, those principles. Experience at Ford Motor, where the hood wasn't properly grounded, let electromagnetic noise get out. We couldn't pass the truck in Canada and get it sold. So all these things in my experience, a land phone, that's when we'll talk about single point grounding. It kind of worked until the vice president came down and put his cell phone next to it as he tried it, and you could hear all the noise from the cell phone get in, bad grounding. So don't think we're beating a dead horse here. We're going to talk about grounds for 3 or 4 more of these schematic episodes. There'll be Atmel Edge episodes about debuggers and programming, and there'll be Edge shows about PCB layout and some project shows I know you guys will like. So for now, it's the tagline of the show is well-rounded, well-grounded. And that's part of the grounding, it's the double entendre of understanding this grounding is the very first thing you need to understand as you draw schematics. And once we get through this, then we'll start talking about CAD packages and symbols and all of that good stuff. For now, this is the Atmel Edge. I'm Paul Rako. Stay tuned. You'll be well-rounded and well-grounded. Thank you.